I'm Matt Dickinson from the Northern Research Station, and I'm a research ecologist there and work on fire behavior, fire effects. And I was part of the RX Cadre project a number of years ago, which was really appealing to me because it's not possible to make all the measurements that you would want yourself. Too expensive, don't have the expertise, etc. So it was really helpful to have people of very different backgrounds and interests all working sort of collaboratively on these measurements. A lot of what we're doing here and for RX Cadre was trying to describe the fire's heat budget. So, and if we know what the radiation is accurately, then, and also take measurements at the same time of the convective flux, of fuel consumption, flame characteristics, and so forth, we then have a set of data that we can use to relate any overhead measurement to better understand what's going on in the fire. And one of the key questions we're trying to answer here is to separate out radiation from hot soot in the flame, hot ground, hot fuel particles from radiation emissions from gases, which are difficult to measure. And typically the satellite measurements, they're trying to avoid the parts of the infrared spectrum that radiate from hot gases. They're called atmospheric windows. So they're trying to measure right in these atmospheric windows. They're measuring the soot emissions, hot soot emissions, hot ground, hot fuels, but they're trying to avoid all that gas emissions. But it's a really important part of the radiation, the sort of the total radiation of the fire. So we're trying to figure out how much of the radiation is this ideal black body radiation and how much is coming from hot gases. And so we'll be better, sort of able to correct, in a sense, a lot of the measurements from aircraft and satellite. Eventually, once we get to a point where we're happy, we can better use those measurements to answer ecological questions, which is ultimately my interest being an ecologist. So.